This video is the explanation to the answers to the June 2018 Chemistry Regents Exam. We are going to go through the first 30 questions of the exam, which are known as the Part A questions. So let's get started. All right, so for number 1 here, you're asked about describing the charge and location of an electron in an atom. You should know for all 3 subatomic particles, your protons, your neutrons, and your electrons, where they're located in an atom and what their charge is. Okay, protons are positive, neutrons, they have no charge, electrons are negative, protons and neutrons are found in the nucleus, electrons on the outside. Now, with that information, it's real simple to answer then this question. It's just a fact. It's choice 3. So if you did not know the answer, you got it wrong, or you guessed, make sure you write it down. And I would suggest getting yourself a piece of paper and a pen right now so you can jot down like notes as you go. And then study them. So when you're practicing more questions or you're going over the same questions, you won't make that mistake again. All right, we're moving on. All right, so for question 2, it's asking why a xenon atom is electrically neutral. Well, it's not just the xenon atom, folks. It's any atom is electrically neutral. And that is because for atoms, the number of protons is equal to the number of electrons, right? Protons are positive, electrons are negative. And there it is. It's a fact. Once again, choice 4. All right, let's go to question 3. 2 atoms of isotopes of the same element. The atoms must have isotopes. You need to know the definition for isotopes. I've talked about it on other videos. If you don't know the definition, stop the video, write it down right now. And it is, of course, the same number of protons, different number of neutrons. Some way, shape, or form, an isotope question shows up on every exam. Let's move on to question 4. With question 4, we're asked about electrons in a calcium atom in the ground state that's going to have the greatest effect on the chemical properties of calcium. Well, for any atom, it's the outermost electrons for that atom that are going to have the greatest effect. So it means we need to go to the periodic table and look that up for calcium. Now, if you do not know the symbol for calcium, then you're going to start at reference table S. It lists the element names and the symbols. Find it, then go to the periodic table. Calcium symbol is Ca, and here it is. It's element 20. You want to write down the electron configuration right here by the question, 2882, again for calcium, which is Ca. So the outermost energy level, you read it from left to right. The first shell, second shell, third shell, fourth shell. In the fourth shell, the valence shell, 2 electrons. That makes the answer here for number 4, choice 2. Question 5, we're looking for the weighted average of atomic masses of the naturally occurring isotopes. What you're reading there, or I'm reading to you, is the definition for atomic mass of an element. Atomic mass of an element, again, is the weighted average of the atomic masses for the naturally occurring isotopes. A lot of times on Regents exams, you're asked to calculate the atomic mass. You'd be given the mass of the isotope and the percent it's found in nature. Last year's June Regents, instead, they were looking for the definition. So if you didn't know the answer was atomic mass, write it down with the definition. Let's go to number 6. Which element is classified as a metalloid? These are the elements that have some properties of metals and some properties of nonmetals. Once again, if you don't know what the answer is, first thing is look at the periodic table whether you think you do or you don't. and there are 6 that you need to know. If you don't know them, you're going to memorize them. So let's go to the periodic table. The metalloids, also known as semimetals, are the following. They are the 4 elements on what I call the staircase: boron, silicon, arsenic, tellurium, and 2 below, germanium and antimony. All right, so you should know they're around or on the staircase, and the 2 below. Don't think aluminum is, right? Think aluminum foil, that's definitely a metal. All right, remember 2/3 of the table are metals, and over on the right here we have our non-metals. So it's going to be one of these 6. So let's go back to the question. The answer then is going to be choice 4. Let's move on. Which statement describes a chemical property of iron? Well, iron, you should recognize it's an element. If we have a chemical property, then it's reacting with another element or compound. Properties are going to change. So chemical properties, it's not going to stay the same. One of the words or keywords to indicate that would be the word oxidize or oxidizes. Other words would include reacts with, neutralizes, trying to think of some other ones, combustion. So these would be keywords that indicate either chemical change or chemical properties. For physical, some of the examples are here, right? Iron is a solid at STP, that's phase. Iron melts, that's a phase change. Iron is attracted to a magnet. It does not change the chemical properties. So, chemical properties and physical properties. Just know the list. In question 8, it's talking about graphite and diamond. Hopefully you recognize those 2 words. Those 2 words are different forms of carbon atoms bonding to other carbon atoms. Now, there is a vocabulary word known as allotrope. Don't confuse it with isotope. This definition, they never say the word allotrope, but you need to know we're talking about the same atoms, but different structures. Different structures result in different properties. So the answer is choice 2. So just make sure you know same elements, different structure, different properties. Number 9, which ion has the largest radius? Well, these 4 elements are found on the reference table. So let's take a look and I'll explain it from there. Fluorine, chlorine, bromine, and iodine are in the group known as halogens. They're here. They all want to gain 1 electron, so that's why they all have the minus. When it comes to atoms, as you go down a group on the periodic table, the size of the atoms increase. And since they're all gaining 1 electron, that trend would still be the same. And the largest is going to be iodine. Choice 4. For question 10, we're dealing with carbon monoxide, which is CO, and carbon dioxide, CO2. And what do they have? Well, they are different compound formulas. Even though they contain both carbon and oxygen, they are going to have different chemical properties and different physical properties. So every compound has its own physical and chemical properties. Every element has its own physical and chemical properties. For question 11, they talk about here, table S, which group on the periodic table has the element with the highest electronegativity. So electronegativity, another one of those vocabulary words you should know the definition too. It has to do with the pull an atom has for electrons. Electronegativity values are on reference table S, but since we're dealing with groups 1, 2, 17, and 18, the first thing you want to do is go to the periodic table. So let's do that. So let's go ahead and circle. We're just going to go with the second row or period of the periodic table. Talked about group 1, 2, and then 17 and 18. And which one has the highest electronegativity? Well, some students might take the bait. This could be a trick question. What you would want to do to make absolutely sure is go to reference table S, which we'll just look up the values on reference table S. And this is the reason why I say that. The noble gases were never assigned electronegativity values because they don't want to pull electrons. They don't want to push them. They just don't want them. They're very stable. So they would have an electronegativity value of 0. So it's really up to lithium, beryllium, and fluorine. Now, you might have heard many times from your teacher, I know I say it all the time, fluorine is the most electronegative element on the periodic table. But to make absolutely sure, or if you forgot that, you want to look at reference table S. So this is reference table S. I want to find lithium, which is 1, beryllium 1.6, and fluorine, there it is, 4.0. Neon, I just covered it up, has the dash. So the winner is fluorine. For question 12, which is represented by the chemical formula PbCl2S. If you see an S in parentheses, an L in parentheses, or a G, you're talking about the phase, in this case for a substance, more specifically a compound. So a compound or an element, when you see an S, an L, or a G, that's the phase. I do want to point out to you that if you saw a formula and a Q, remember AQ means water, you would have then a homogeneous mixture. But for question 12, the answer is choice 1. Looking at 13, we're asked about the vapor pressure of propanone at 50 degrees Celsius. You're not guessing here, folks. It's on the reference table. So let's go take a look. So here it is, reference table H. This is known as the vapor pressure diagram. And we were dealing with 50 degrees Celsius and propanone and looking for the vapor pressure. So I find my 50 line and I go up. I see where it crosses the propanone curve, and then I go ahead and I read it here. All right, so on the y-axis here for vapor pressure, it's going up every 10, so 50, 60, 70, 80, just around 80 kilopascals, maybe a little bit more. I'm going to go ahead and go back to my choices now. And the closest to the 80 is the 83 kilopascals. So for question 14, it's asking about charge distribution and the polarity of methane. Methane, CH4, you might remember is a tetrahedral shape. Since all 4 bonds are going to be the same, we have what's known as a symmetrical molecule. So first thing you're going to do is cross out choices 2 and choices 4. Then to remember, symmetrical goes with nonpolar molecules, asymmetric with polar. Just remember, it's a synap. Symmetrical nonpolar, asymmetric polar. And that makes the answer here 14. I'm sorry, 1 for question 14. All right, let's check out 15. We're dealing with a lab investigation. Student is separating colors of a mixture and is using paper chromatography. The colored compounds separate because of differences in. So remember, mixtures are just physically combined, and we're looking for the physical property that's going to separate them out. And it turns out the answer here has to do with molecular polarity. Molecular polarity has to do with whether or not one substance would dissolve in another. For example, salt dissolves in water, but oil doesn't. Well, oil and water have different polarities. Salt is an ionic compound, and salts typically dissolve in polar compounds. Salt will not dissolve in oil. So molecular polarity is the answer here. You should review some of the other separation process, right? We're talking distillation, filtration. This one's chromatography. And if I remember any more, I'll let you know. Okay, we're up to question 16. So we're halfway through part A. And I hope you see that there are a lot of vocabulary words you need to know, facts, and to rely on those reference tables. So let's continue with question 16. It's asking about a phrase that describes the motion and attractive forces of ideal gas particles. So once again, you're supposed to know what the phrase is. When we're dealing with ideal gases, we're dealing with this theory called kinetic molecular theory, and we're saying gas particles, if they're ideal, are following certain protocol. One of them is that they move in a straight line. One is they have no attractive forces. Another is we're ignoring the volume those gas particles take up. They are facts that are associated with ideal gas particles. No real gases are always ideal. The best conditions for any real gas to behave as an ideal gas, this is another thing to memorize, is under high temperature and low pressure. So with question 16, the answer here was choice 1. All right, for 17, it's asking which temperature will mercury as a liquid and mercury as a solid reach equilibrium in a closed system. Well, if you've got a liquid and a solid present, we're dealing with, of course, the melting point, or we could also call it the freezing point. Don't guess. You need to go to reference table S. So we're looking for mercury and we're looking for the melting point. Sorry, this is so small. Find it on your reference table. We're talking about element 80 and we need the melting point. The melting point is 234. So that's our answer. Let's go back to the test. So here it is for question 17, choice 1. All right, 18. A molecule of any organic compound has at least one. It's not going to be organic, folks, without carbon. It's a fact. You need to know it. All right, 19. Chemical reaction occurs when reactant particles. Well, this has to do with the kinetics unit or kinetics and equilibrium. Probably did both together. Particles have to collide with the proper energy and the proper orientation or angle. Again, it's a fact. It's called the collision theory. Choice 3. Let's move on to question 20. Systems in nature. Hold on, let me go ahead and bring this up. Systems in nature tend to undergo changes towards, well, more stability is what nature wants and more disorder. So it wants exothermic reactions and it wants, again, more disorder. Exo or endothermic reactions have to do with what's known as enthalpy or delta H. So lower energy, so cross out right now, 3 and 4, and then higher entropy, choice 2. It is a fact. You need to know it. If you don't know it, write it down and memorize it. Let's go to 21. Which formula can represent an alkyne? All right, so you see carbons and hydrogens. There is a reference table that can help you easily answer this question. So let's go. So this is one of 3 organic chemistry reference tables. There's P, this is Q, and there's R. So we're looking for the word alkyne, and here it is. More importantly, we're going to use this formula, and we are going to figure out, we're going to go back and figure out which choice makes the most sense. So the alkyne general formula was CnH2n minus 2. N means the number of carbon atoms. So if I take a look at choices 1 and 2, I'm dealing with 2 carbon atoms, and choices 3 and 4, 3. So let's plug it in. So if N is equal to 2, that would be C2, and then for H, it would be 2 times 2, which is 4, minus 2, which is 2. Well, that can't be then choice 1 or choice 2. It doesn't match. It's got to be 3 or 4. Let's try C3 and then H. 2 times 3 is 6 minus 2 is 4. So the answer is choice 3. Well, this is Jake, and this is known as a Jake break. And what we thought is we just would give you some words of encouragement, right, Jake? We are on question 22. We got 9 more here on this last page for part A. So keep working hard. When you hear weird noises in the background, know that Jake and also Ringo, they're both dachshunds, are around. And let's continue. See what I mean? Question 22. We're given a compound. It's actually a structural formula for an organic compound. I know that because there's carbon atoms in the compound. And we're asked which of the following choices represents an isomer. So the first thing you're going to want to do is count up the number of carbons, which is 4, and then count up the number of hydrogens, which I'm going to just start here and go around 1, 2. I'm just making a mark. You should too, so you know where you started. And it's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 of them. So I'm looking for a choice that has 4 compounds and 10 hydrogens. And you could just take them in order. For choice 1, I know right away it's not the answer. It's got the 4 carbons, but take a look. It only has 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Can't be it. Choice number 3, which is right here, it's got the 4 carbons. It's got even less hydrogens. That can't be it. So now what I have to do is I just have to bring the other choices into view, and we'll figure this out. Well, if I take a look at choice 2, I have my 4 carbons here, and I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This looks good. Now with choice 4, I got 4 carbons also, and I have 10 hydrogens. This is just the flip of that. When molecules are flipped, either top and bottom or side to side, that's not an isomer. That's not a rearrangement of the atoms. That's just the same molecule drawn differently. So the answer is choice 2. So 23, it says which energy conversion occurs in an operating voltaic cell. Voltaic cell has to do with the unit called redox. With a voltaic cell, we are going to take chemical energy and convert it to electrical energy, just like a battery. So it is choice 1. How do I know that? It's a fact. You make sure that you remember it. For 24, which process requires energy to decompose a substance? Well, I go through the choices. Electrolysis This is the other type of cell you can have, an electrolytic cell, where you take electrical energy and you break apart a substance, and lo and behold, that is the answer. Now let's go through the wrong choices quickly. Neutralization means I have an acid and a base forming a salt plus water. That doesn't fit the question. Sublimation, you should know this word as well, is a substance in the solid phase directly going into the gas phase. That's not the choice either. And decomposition, which is one of the things we were looking for, the opposite is the coming together of a substance known as synthesis. So choice 1 is the answer. For question 25, we're looking for the concentration of which ion is increased when lithium hydroxide is dissolved in water. Well, it doesn't say the words acid, base, or neutralization, but this is a base. You can take a look at the reference tables for common bases, and what we have based on Arrhenius's theory is the hydroxide ion. So the answer here is choice 1. Now, don't confuse hydroxide with the word hydrogen ion, hydronium ion, or for that matter, halide ion. They're all different words, which means they are all different ions. All right, 26. Which equation represents neutralization? We just went over that. It was not the choice in one of the last questions, but I'm looking for an acid to neutralize a base. So just like 25, let's go to the reference tables just for a second. As soon as you identify you're dealing with acids and bases, I would definitely open up the reference tables for reference table K, which is acids, L, which is common bases, and M, which is indicators. So neutralization means I have an acid reacting with a base. So more than likely, you're looking for one of these formulas, or if not, something that either starts with H, or if it is an organic acid like ethanoic, it would have COOH in the formula, and you're looking for a common base. For the common bases, you're looking for a metal, NOH. The exception down here, you can't see it, it's blocked right now, is ammonia or NH3. That's also a base. So let's go back to the question. So if I go through the choices, choice 1, I have lithium and nitrogen as my reactants, no acid or base there. So that can't be it. Choice 2, magnesium and oxygen, not an acid or a base. That can't be it. It is, yes. Choice 3, KOH is a base. H2SO4 is an acid. We're forming a salt and water. Choice 3. Okay, we're down to the final couple of questions. For question 27, the stability of an isotope is related to its ratio of. When we're talking about stability of the inside of an atom, the nucleus, we're talking about the ratio of neutrons to protons. So in nature, most of the elements, their atoms, the nucleus will not decay. However, as more and more protons are added to an atom, eventually, because they're all the same charge, even though nature throws neutrons to space them out, they become radioactive. So again, the stability is based on this ratio. All right, a couple more to go. All right, for 28, which particle has the least mass? So alpha, beta, neutron, or proton. Now you might know this just flat out. The answer is a beta particle. Beta particle is actually an electron that originates from the nucleus with a transition of a neutron going to a proton, and I call it an electron because it has 0 mass but a -1 charge. Alpha particles are 2 protons, 2 neutrons, way too heavy. Neutron and proton have the same mass. We say 1 AMU, so the answer is choice 2, or beta particles. Okay, 29. Energy released during a nuclear reaction is a result of nuclear reactions. You're going to get a ton of energy, and that goes back to E is equal to mc squared, which is Einstein's famous equation. So that is mass being converted to energy. It is a fact. So nuclear reactions blow any kind of chemical reactions away as far as energy. So know it. Let's go to the last one here in part A for 30. The use of uranium-238 is used to determine the age of a geological formation. It's a beneficial use of, and that would be not fission, not fusion, no radioactive isomers, it's radioactive isotopes. So radioactive isotopes can help us with things like aging, or maybe radioactive isotopes when it comes to fighting cancer or determining if somebody is sick with cancer. So this ends part A. Good job if you made it to the end of the video. And sure enough, we have some more parts coming up for the June 2018 Chemistry Regents Exam. Keep working hard and good luck.